This is Brian Putt. I want to walk you through an example of generating a Metalog, which is available in SIPmath. There's no right or wrong way to model these things or set them up. It depends on the number of Metalogs and the purpose. I'm just going to generate one Metalog. So let's go to the Excel model. So I've set up the model where I can specify a P10-P50 90, and I can specify a lower bound and an upper bound. I guess I need one more variable, which is the type of distribution. The first thing we need to do is to initialize our model. So I'll go to SIPmath, initialize. We'll do 1,000 iterations. Because I want to do a Metalog, I'm going to put that on a separate worksheet. Doesn't have to be, but I kind of like to put them there. So I'm going to SIPmath, generate input, Metalog, and we'll do a vertical. Actually, we're going to do a horizontal. And the reason I'm going to do a horizontal is my original data, my 10-50-90, is in a horizontal position. That'll make it easier to copy it across. And we'll include the charts. So here is the inputs. And now I simply need to link the data on this model worksheet with the data that's on the Metalog worksheet. So my P10 is equal to my P10 over here, and the 50 and 90 are the same. The result is shown over here on the Metalog. Let's give that another digit here. And we'll give that a name of D_Metalog, SIPmath, define outputs, give the spark lines. Oh, I need to specify the name here. Point to that name. And then I can generate a graph of that. We'll put the histogram here, and we'll put the cumulative here. And there is our Metalog. You can see that it's asymmetric. And if I change this to a 15, it now looks very normal looking. However, we want to make use of the lower bound and the upper bound as well. So let's put in a type of distribution here. So let's put in a B here. This all has to be lowercase, by the way. And we'll say equals model B. Now everything is fine, except now I have to specify lower and upper bound. So I'll come over here and say that's equal to my model lower bound. And the upper bound is equal to the model upper bound. Okay, it still doesn't like it because the upper bound isn't defined, and it's also 0, I guess, if you will, and it's less than 15. So let's put in a 20 here, and let's put in a 2 here. Did you notice how this graph moved back a little bit? I'll put the 0 back in there. You can see how it's moving just a hair. Okay. I could also make this distribution just have a lower limit. So now it's going to have a lower limit of 2, but no upper limit. You'll notice how the graph moved out here to the right. I'll tell you what, we'll do this. We're going to fix this. I'll fix this at 50. Okay. So now let's try something else. We can make this is kind of a symmetrical distribution in the middle, but you see it's not symmetrical in the tails. So that's why it looks the way it does. So now let me change this to an asymmetric in the middle. Let me put a 25 here. Let me put a 40 here. Now, I'm still getting an answer because I've told it's SL. If I tell the model that it is a SU, I now have just an upper bound and no lower bound. You notice how this goes down to 0 now versus the bounded, which looks different. SU. Okay. So that's how you can set up the Metalog and specify the inputs. So these would be all inputs as well as that SU. Thank you for watching. If you want to learn more about SIPmath or Metalogs, you can visit probabilitymanagement.org. You can download the SIPmath toolbar there. And you can go to Tom Keelan's website at metalogdistributions.com. You may also be interested in watching some of my YouTube channel videos on SIPmath, different applications. And you can contact me at brian@theputz.com. Thanks again.